Paper and film in the film paper. Sir, I'm in paper and distribution or in the sort of
almost teaching and the natural passing over.
So the world is slow.
Moon the problems very. Why would the Nama do to but they could have concentration. You go out of the
Only chapters are preparation.
Or continuous to none partnerships in none there.
ಇದು ಸೆಕೆಂಡ್ ಪೇಪರ್ ಸೆಕೆಂಡ್ ಒಳಗೆ ಎಲ್ಲವೂ
ಸಾಕು ಮಾಡಿ ಮಾತಾಡೋದು
ಹಾಕಿದ್ರಿ ನಾನು ಹಾಕಿದ್ರಿ Caution.
recording ಕೊಡ್ತೀನಿ Hello everyone. Today we are going to start your second paper, final year second paper. In this semester, you are going to study the two papers in physics. In paper 2, there is a first chapter named as quantum mechanics. In that second half, I am going to teach you in this semester. The topic is second topic is laser. Second half is laser. Laser. You all are very familiar with the chapter name and the word laser. Very familiar with the laser. You already know some applications of the laser. But in this chapter, you are going to study the construction and the working of the laser, and wherever the applications of the huge number of applications in the laser, and you are coming to know the principle of the laser. Based on this topic, you are going to carry on the some experiments with the practicals also in this semester only. Based on this topic, based on this concept, you are going to experience or going to perform the experiments on the topic laser. Before going to know the laser, just we are going to study the what is photonics. Just to know the photonics. What is photonics here? Usually, if we are going to study the some reactions, means or else atom. If we consider the atom, this atom consists of nucleus and photons and neutrons. Right? Photons and neutrons and electrons togetherly called as an atom or a molecule. Electrons are revolving around the nucleus, and this nucleus consists of a number of protons and the electrons. Whenever we are going to consider the excitation energy, excited electrons, we are going to study the excitation of electrons in case of electronic configuration in our already set. Study of photons. Study of photons is called as photonics. Photonics, study of photons. Generation of photons. Generation of photons. Propagation of photons. Of photons and also we can know the detection of photons, which includes study of photons in which the generation of photons, propagation of photons, detection of photons, these togetherly called as a photonics. How the photons are generated, how the propagation of photons, where we find out the photons. This is called as a photonics. So in this photon is a fundamental ingredient of the laser. Photon is a fundamental ingredient of the laser. Photon is fundamental thing or the fundamental matter. We can say it as a matter. Fundamental thing. Thing of the laser. If we have the photons in the atoms, the propagation of photons, then only we can study the laser. And this laser spectrum of the laser. What is the laser? Usually if we ask what is the laser? Laser is the having this diagram, light amplification, light amplification by stimulated emission. Stimulated emission. Or if we ask what is the stand form of the laser means, we have to say that the light amplification by the stimulated emission. What it says? Amplification. Amplification in the common name, you can say that which is generated, collected, or amplified means which is stored, amplified, collected. You can say that. How the light is amplified means how the light is gathered, collected by the stimulated emission. Light is gathered or the collected by the stimulated emission. You will study the next part as a stimulated emission. Some other types are there, right? It is not the definition of the laser. It is not the definition of the laser. Then what we can call the definition of the laser? Laser is a device. Laser is a photonic device. Laser is a photonic device in which coherent basically it is called as a photonic device. Photonic device in which coherent, what is the key points here? It is a coherent, it is having the coherent one and highly monochromatic. It is highly monochromatic. Right? And it is parallel beam of light. It is having the parallel beam of light. How can you say this one? Basically, a laser is a photonic device in which light is having the coherent one, highly monochromatic and parallel beam of the light. What is a coherent? Coherent means there is a same phase of the light wavelengths. The difference between the two waves, difference between the phases of the two waves, that is having the same phase of the wavelength, then it is called as a coherent one. Coherent. If we call it as a incoherent means which are not having the direction. Another word of the coherent, we can call it as a unidirectional. And the one, another word we can represent a coherent as a unidirectional. The waves which are coherent means which are having the same phase. Same phase means these are in a restricted space. These are in a restricted space. It is not scattered in all direction. Light, usually the ordinary light or the normal light, when we are considered, they are scattered in all the direction. If the light or the light tube light, whenever we start the light, it transmits the light or the rays in all the direction, but not those are called as a incoherent one. But here in laser, if it is a coherent one, we can say it as a unidirectional one. It is passing in a perfectly constrained space. It is traveling in a constrained space. Having the each wave difference is same here. Each wave difference is same here. But in the incoherent, there is no same wave difference in each the wave. It is the difference between the coherent and the incoherent. This is the one property of the laser. And what it says as a second one, there is a highly monochromatic. Highly monochromatic. Name itself it says that a monochromatic. Monochromatic, which one is having the one colored light, one colored, highly monochromatic. We are saying it is not the mixture of the all lights. And if we say the light is a mixture of all the colors, it is a composite of the colors. But you know that in the last spectroscopy experiment, B.Sc or all the colors having the different wavelength, all the current lights having the all the colors having the different wavelength. Yeah, yellow is having the different wavelength value, red is having the different wavelength, and this wavelength is differs with the intensity, differs with the intensity. Which one is having the high intensity? It's having the low wavelength, right? With GR, according to the order, it is going to change the wavelength value. Which one having the single wavelength value? The wavelength which having the one value, single wavelength value, then it is called as a single color. Only the value of the wavelength is same. Wavelength value is, if the wavelength value is same, then we can call it as a single color, that is the monochromatic. it doesn't changes. Monochromatic, right? Monochromatic. And the parallel beam of the light. As I said, it is passing in a unidirectional. Of course, it is a more parallel beam of a light. All the wavelengths here I said that coherent sources having the same phase of the wavelength. See, if the same phase of the wavelength, look at this one. This is parallel to this one. Crust, rough is parallel to each other. Then it is called as then it is called as a parallel beam of the light. How can we say the definition of the laser here? The laser is a photonic device in which it is a coherent one, highly monochromatic, and it is having the parallel beam of the light. Coherent light, monochromatic, or a parallel beam of the light. This is the definition of the laser. Light amplification by the stimulated radiation. It is called as a stand form of the laser. Right? And this photonic concept, this photonic concept is widely used in the world now. At present, you are going through the online classes. This is because of the photonic concept. Because it is having, when we consider the photonic concept, here it includes the study of photons. When we taken the photon as a concept, there is a no loss in the energy. There is no loss in the energy, and it is a very high speed for the communication, either in the video purpose or in the audio purpose. That's why the photonic concept going speeder now. In that, we are going to study. We have studied the laser concept there. So we came to know that what is the standpoint of the laser and know the definition of the laser. Then how come the laser is constructed? How the laser is constructed and how the working process of the laser here. Before that, many types of a laser are there. First discovered laser is a ruby laser. Ruby. First discovered laser is a ruby laser. But the types of laser is types of laser are first one solid laser, second one gas laser, and third one some other lasers which are like other lasers all includes in this third kind. Those are a chemical laser, semiconductor laser, biolaser, free electron laser, and some other laser are there, but these all the laser includes the kind of third part of the laser, solid laser, gaseous laser. This gaseous laser further divided and further classified as a helium neon laser. It is a helium neon laser. So we are going to study the what are the steps included in the construction and the working of the laser. What are the steps included in the construction and the working of the laser? In this step, First one is stimulated absorption. Stimulated absorption. Absorption. And the second one is spontaneous emission. Spontaneous emission. And third one is stimulated emission. Stimulated emission. Stimulation. Here, what may include absorption. Absorption of the water by the some other external factors. Absorption of the photons. It is the first one. And what is the spontaneous emission? Spontaneous says that instantaneously, without an external factor. Some other example, how can we say that if you slap to someone, spontaneously you return it back, right? Then like that only. The spontaneous emission. Instantaneously we will react to that one like the spontaneous emission. After the some reaction, there is a emission. There is emission within a few seconds. Hence, we will call it as a spontaneous emission. Right? Stimulated emission. What is the stimulated emission? Here, what I said that stimulated absorption. Absorption means gathering or collecting the photon. Emission means revealing, expelling the photons. That emission is spontaneous. Emission or expelling the photon within a short time period without adding external factors, then it is called as a spontaneous emission. Here there is an emission but not the spontaneously. Of course, it also takes the small time period, but it is external factors. So let me study that one by one in detail. This is before absorption. This is the ground state. And there is an external factor, electromagnetic radiation, HCD. During absorption. During absorption, this after absorption. See this one. The process of the atom in the ground state, the process of the atom in the ground state undergoes the transition to the another state, undergoes the transition to the excited state. Then it by the electromagnetic radiation, then it is called as a stimulated emission, stimulated absorption, which undergoes the transition here the excitation of a photon to the excited state, from the ground state to the excited state. This process is called as a stimulated absorption. Let us consider the photon. Let us consider the ground state E1 here and the E2 here. Even and the E2 here. It can move in the ground state to the excited state. How it is going to move it? How it is going to move from a ground state to excited state? We should require some external factors. So electromagnetic radiation is applied to this one. After the application of this one, this photon is excited to the higher energy level or the excited energy state. Then it is called as the stimulated absorption. This is the pictorial representation of the absorption before absorption, during absorption, and the after absorption. Look at this here. There is when we are going to see this reactions, we are having this some energy with the photon. This energy with the photon is going to be transferred in this stage, stage, and after this stage, photon is with the energy h. Photon is with the energy h. Photon is with the energy h. How can we know the energy after the absorption? Just we are going to say that if we want to get the value of h nu, Planck's constant and the frequency of the photon, E2 minus E1. There is some extra energy added to the photon. There is some extra energy added to the photon due to the external factor, electromagnetic radiation that is added to the photon, and togetherly it is subjected in the higher state or the excited state. Hence, we can calculate that how much of energy is received by the photon to go to the excited state. That is can be calculated by the E2 minus E1. E2 minus E1. This is and this stimulated absorption. The rate of the stimulated absorption depends on rate of stimulated absorption depends on it. E1 and E2. How we can represent this reaction? I am going to write here atom plus photon, that is equal to atoms. Is equal to atom upgraded atom with the energy, upgraded atom with the having the more energy atom star. Right? This atom star, how the energy is added. So how can we get what is the value of a photon here? We can represent it H nu and this one as a E1 and this one as a E2. So we can write that H nu. If we want the value of H nu, E1 and E2 are the new factors. Before the absorption of the before absorption and after absorption, we will get to know the value of E1 and the E2. So the photon value is the unknown here. H nu is equal to E2 minus E1. E2 minus E1, this represents here, right? And how the simulated emission is depends on the some other factor. How can I say that? This is directly proportional to the stimulated absorption. What I am going to represent this one as a R. R1. R1. Right? R1. Yes, look at this one. R1 is directly proportional to R1 is directly proportional to the N. The first N. What is this N? There is a number of photons in the lower energy state. Number of atoms available in the lower energy state. So lower energy state, we can represent this one as a N1, and it also proportional to the rho. What the rho indicates that density. Density of what? Density, energy density of incident radiation. Incident radiation. This radiation. Density of this radiation. This is affected to the both the states. Hence, we can represent this one as a 2 1 again state 2 and 1. How can we write this one? R1 is directly proportional to the rho to 1 and N1. For removing this proportionality constant, we are going to write the proportionality symbol. What is that one? R1 is equal to B to 1. It is the Einstein coefficient. We will study it in next class. That one. Rho to 1 and 1. This is the value for the stimulated absorption. Stimulated absorption represents R1 and this one is directly proportional to the N1. N1 is called as N1 is indicated by the number of atoms present in the lower energy state, and the rho indicates that the energy density of the incident electron radiations. And this is the constant of the Einstein coefficient. This is the constant of the Einstein coefficient. Let us study the second one. Let us study second one. What is that the topic? Spontaneous emission. Emission. Spontaneous emission. As we study here, there is absorption of photon. After the absorption of photon, there is instantaneously, spontaneously, there is an emission of that photon again. Instantaneously emission of that photon again. Then it is called as a spontaneous emission. Here there is an emission of photon. Emission of a photon. That says that incident photon. How much the incident photon having the value, it expel out the incident photon. Suppose, for example, there is an atom in the before stimulated absorption. There is atom in the ground state. It emits to the higher state, or it absorbed by the higher state. During the absorption, there is a it absorbed by the higher state. After excitation of the higher state, the photon with the energy H. If it is unstable, if it is and it is unstable, within the short time, it is about 10 raised to minus 8 second. Within very short time, it emerges out, it expels out. Expelling out the photon with the energy, it is named as emission. It is within the short time period, hence it is called as a spontaneous emission. How can we write this one? In the second stage, we are going to consider it by the absorption only. After the absorption, right? Atom is going to splintered up to the atom plus photon. It is the reverse factor of stimulated absorption. Stimulated absorption is the ulta factor ಅಂತ ಹೇಳ್ಬೋದು ನಾವು, right? And how we can write the formula for this one? R2 is directly proportional to this one is also depends on the number of atoms only, but the number of atoms where it lies in the excited state, hence it is named as N2. But in the excited state, photons are lies with the extra energy, heavy energy, more energy than the ground state, right? And it is also directly proportional to the, again it depends on the density of incident photon. So that incident photon is applied to the both the states, hence we are saying this one as root 1. And how can we represent it? R2 is directly proportional to the n2 root 1. Right? For removal of this proportionality constant, we can say that R2 is equal to A21 into rho 21. A21 into rho 21. Right? This is the formula or the general equation given by the spontaneous emission. Right? Spontaneous emission. Let's move towards the stimulated emission. This is spontaneous emission by the natural cause, not using the external factor. Here, stimulated emission. Stimulated emission. Stimulated emission is here. How we are going to say that there is a photon, and look at this. How the picture represents in the first one. There is a photon incident into the ground state, right? And there is a photon releasing from the excited state is a spontaneous emission. Photon incidenting to the ground state is the stimulated absorption. Here photon is incidenting and the photon is expelling out. These two factors includes in this stimulated emission. As I said before, one stimulated means which is apprised or motivated mind to remove it out. Where from where it remove it out? From the excited energy, it is going to remove it out. In this one, if there is a instead external factor we are using. Incident photon interacts with the higher energy level photons. Incident photons interacts with the higher energy level photons and it expelled out with the two photons. It expelled out with the two photons. It expelled with the two photons. So how can we write this one with the atom? It is expelled with atom plus two photons. Expelled with two photons. It is affected by the external factor. It incident to the higher energy level, not the ground state. In this one, there is an incident of photon, incident of electromagnetic wave radiation to the higher energy state, and it expels out two photons from the higher energy level. But these two photons are both are having the same energy as identical to the energy as identical to the incident photon energy as it is identical to the incident photon energy. This is all about the stimulated absorption, spontaneous emission and the stimulated emission. Further we discuss in the next class.